Hello everyone. Today I will be presenting my term paper, Advancement of Parallel Processing with Cloud Computing. Let's get started. Gordon Murray once predicted that the number of transistors present on a single integrated circuit will double every 2 years. This observation became a guiding principle for the hardware industry for the coming years. So the performance and speed of the CPU improved after every 2 years. Even though these new developments of hardware technology led to a better output and performance, the performance achieved by CPU became stagnant after some time. So, in order to overcome this problem, the hardware industry shifted their focus on parallel processing. Parallel processing split a single task into multiple subtasks among multi-core processors. Many researchers took advantage of these multi-core processors to develop various parallel processing models, but they were not enough to handle the growing demand of the industry. To handle the increase in generation of data and to increase the performance of hardware, cloud computing was introduced in parallel processing. So let's discuss some of the problems faced in existing parallel processing models. First of all, one of them is the problems of existing models is the inability to divide the task equally among the servers. If one of the jobs is taking longer than the others, then the purpose of parallel processing is defeated due to overhead of the longer job. Second is concurrency issue. If one of the subtasks is dependent on another subtask, then there is a need to maintain synchronization between these tasks. The existing CPU models are unable to provide such kind of synchronization between these subtasks. Then there is a difficulty in debugging and analysis. Since a task is being processed by more than one server, the failure can occur anywhere. So to find the failure point and try to debug it is a difficult task in itself. As the number of servers working on the task keeps on increasing, it becomes difficult to check and debug every server to find the bug or error. Then there is a problem in converting sequential tasks to parallel tasks. Here the existing models have to keep pay attention on how a single task is divided into multiple subtasks. The subtask needs to be divided in such a way that there is no more workload on one single server. Then there is also difficulty in mapping old models to new models. The existing processors and compilers can't be easily mapped to these new parallel processing models. This poses a huge problem because the inability to map the existing hardware to the advanced hardware can lead to some cost issues. So, in order to remove all the existing bottlenecks in the parallel computation, parallel processing with cloud computing was a good idea. Cloud computing is a technology which enables accessing the resources from anywhere and anytime without any third-party interference. This on-demand availability of resources enabled various small companies to grow and expand their business and profit. It also helped in overall advancement of parallel processing computation. It provides three kinds of services: infrastructure as a service, platform as a service, and software as a service. Now let's talk about it one by one. Infrastructure as a service, all the infrastructure, including storage, networking, data centers, servers, virtualization, everything is provided by the cloud provider, and rest is managed by the customer itself. In platform as a service, the whole platform, including the infrastructure like operating systems, databases, and security, is provided by the cloud providers, and the rest is managed by the customer. In case of software as a service, the whole setup is provided by the cloud providers, and the customer just has to download that setup and execute the applications using their data. They don't have to manage and control anything in this service. Cloud computing provides various benefits. Let's discuss few of them. One of the benefits is it's highly scalable. Additional resources are pulled up and removed from the cloud computing depending on the requirement and workload of the task, making the system more scalable and also leads to better performance and efficiency. It leads to reduced IT costs as well, since cloud offers on demand service, which means that the user is only charged for whatever they use. There are no unnecessary charges. It also balances the load between various servers. Cloud computing provides the service to handle all the scaling up and scaling down of the resources in case of increase in workload on any of the server. It also provides computation at a large scale, since cloud computing enables users to connect to various resources regardless that they are at present in a completely different region. This property has enabled companies to increase the computation to a larger scale globally. It also provides automatic management and updates so that the end users don't have to worry about it. They also maintain the synchronization between multiple servers if these servers are data dependent to each other, which we saw was difficult in existing parallel processing models. There are two existing parallel processing models in the hardware industry which take advantage of the multi-core. One of them is OpenMP, Open Multiprocessing, and the other is MPI, Message Passing Interface. Let's talk about it one by one. OpenMP, also known as Open Multiprocessing, is a multi-threaded parallel processing model. It enables multi-core to run and handle multiple threads efficiently as compared to the normal behavior of the multi-core. It splits the task into multiple subtasks, and after combining the output of all the subtasks, it produces the requisite output. OpenMP allows multiple threads to access shared memory and data. It is an application programming interface API which supports C, C++, and Fortran. Along with this, it also supports various platforms including Linux, Mac, Windows, Solaris, AIX, HP UX. This model also takes care of all the low-level details of how the processor is parallelizing the task and synchronizing all the tasks. The developer just has to specify which task needs to be parallelized and which task needs certain amount of memory, which tasks are data dependent, etc. As we can see from the figure that in OpenMP, the master splits the task between a slave. So when the computation starts, the multicore knows how many threads needs to be created. Here, the number of threads is equal to the number of slaves. After completing the computation, the slave sends the result back to the master. The master waits until all slaves send their results back. After receiving all the results, the master produces the requisite output to the next task or to the end user, depending on the requirement. So as we can see that firstly the main thread is fork between into multiple threads into multiple subtasks, and then the processing is done on each of the single sub multi-thread, and after doing the computation on of each thread, the results are combined by join function, and the overall results are joined by the processor itself. And after joining all the results from all the subthreads, it is sent back to the user or to the next task, depending on the requirement. Another parallel processing model is MPI, also known as Message Passing Interface. This model allows computation between multiple and different architectures. It allows multiple multi-core processors to communicate among themselves. It also handles synchronization between multiple processes, communication regarding data, termination, and initiation of all the process. MPI is basically a standard and portable processing model which can be deployed and executed on various kind of structures. This model also hides the low-level complexity from the end user, just like OpenMP. It also supports C, C++, and Fortran. Additionally, due to its portability, it is easier to deploy in other architectures which does not support C, C++, and Fortran as well. For example, it can be deployed in architecture supporting Java programming due to its property of being portable. As we can see from the data flow of MPI, different tasks are split among different servers. After all the tasks are completed, the results are collected and processed according to the user's requirement. It weighs down each and every result depending on the contribution to the end result. After weighing down all the results and summing up their results, it is sent to the end user or to the next task depending on the requirement. With the help of cloud computing, parallel processing can be performed on a much larger scale with better performance and speed. One of the cloud computing technologies which acts as a powerful tool to perform parallel computation is Apache Hadoop. Apache Hadoop is a collection of open source software utilities that facilitate using a network of many computers to solve problems involving massive amounts of data and computation. It provides a software framework for distributed storage and processing of big data using the MapReduce programming model. It consists of various components like HDFS, MapReduce, and Yarn. As we can see from the architecture of Hadoop, HDFS provides the storage for the Apache Hadoop, and Yarn acts as a resource manager for the Hadoop. MapReduce is the programming model used by Hadoop to perform all the parallel computation on the data. As we can see that Hadoop also follows master-slave framework. Here, name node is the master and the data nodes are the slave. Each name node keeps the information of all the data nodes and the computation performed by that data node. Data node handles the computation on each and every server and sends the result back to the name node. As we can see from this diagram that the name node consists of metadata, which includes the information about the data nodes, like what is the name of the data node, the location of the data node, and which client is able to access those data nodes, and what computation is done by each and every data node. And the data node itself also stores information about various servers. It can be doing computation on more than one servers, and it can be serving to more than one clients. As we can see from the diagram that one of the client is able to write in one of the data node, and the same data node is being used by another client for read function as well. The data node also consists of various blocks of data which help them in the computation process, and it also replicates those block of data on other servers, due to which it is quite fault tolerant. The Yarn infrastructure takes care of all the large clusters present in the Hadoop to handle in the computation, and HDFS provides as a storage, and there is also other cloud technologies like S3 which helps in storage for the Hadoop, and the MapReduce programming model is applied to process all this computation in Hadoop. The programming model used by Hadoop is MapReduce. It processes all the sequential tasks as parallel tasks. In MapReduce model, as we can see that it consisted of three processes. One is mapper, shuffler, and reducer. In map function, the Hadoop takes an input from the user and produces a set of intermediate key value pairs. In shuffle and sorting phase, the Hadoop sort and group together all the intermediate values associated with the same intermediate key and send it to the reducer. In the reducer phase, the reducer processes the intermediate key value pairs to the final result and send it back to the user. To just get an overview of the execution done on the data by Hadoop, we will discuss about it. In MapReduce, the data is sent as an input to the master. The master allocates multiple mappers to map the input data into a key value pair. The mappers map the incoming data into a key value pair. Then these key value pairs are sorted according to their keys and sent to the reducers. The masters make sure that after mapping of data, the data passes on for reducing phase. In the reducing phase, the reducer reduces the key value pairs by combining all the values of the same key into one key value pair. After reducing all key value pairs to respective unique key value pair, the output is sent to the master. Then the master receives the reducer output and gives the requisite output to the user. This whole process is quite efficient, fast, and fault tolerant, and less time consuming. As we can see that there was a huge chunk of data in the starting of the phase, and at the end of the phase there is just one or two files. This is the power of the cloud computing. Here we can see that the user program sends the data to the master. The master further divides, which is like fork operation, and divides the task between various workers. These workers are nothing but are the mappers which performs the mapping in the map phase. The data is split into small data sets named splits. We can see as in the diagram its names split 0, split 1, split 2, split 3, split 4. From these splits, All these small chunk of data sets are assigned to the worker, and the worker processes these data set into key value pair and writes the result into its local disk, which is its local memory. From its local memory, it performs the shuffle and sorting operation. After performing the shuffle sorting operation, it sends back the result to the worker, with another worker, which is simply reducer. This whole process is managed by a master. It also keeps in mind which worker is free, which worker has completed his task, and which worker is sitting idle, and which worker is taking more time. All these factors are balanced out by and handled by master itself. After performing the reducer task, the reducer outputs the single file in all the unique key value pairs. This output is then further sent to the user for its requirement according to its requirement. The need of parallel computation is just growing with future demands. There is an urgent need to come up with better and more efficient models to perform parallel processing on the incoming data flow. Though the already existing OpenMP and MPI parallel processing models can handle the incoming demands of performance and speed, but they won't be able to withstand these pressures and existing complexities. Through cloud computing, we can achieve high performance parallel computation at a much larger scale and handle processing on huge amounts of data. Also, they are quite fault tolerant and more secure due to its various properties. So, to sum up, to improve the performance of existing parallel processing techniques, there is a need to combine these techniques with cloud computing service to advance in parallel processing. Thank you very much.